Okay guys, I'm back out here in my shop, and today is the day we're going to try to bring this thing to life. I've already pulled the Z-axis lead screw back out because I'm going to go back and cut off about an inch where I had it an inch too long. Got the Y-axis all measured, and notice what way I do it is I put tape on there, but I always put an arrow to the side so I remember which side I'm supposed to be cutting to the tape. So that's a good thing to do, because if you're forgetful like me, you'll get up there and cut the other side and then it'll be too short. So I got that ready to cut. I'm going to take some measurements. You see right now I've got these other parts made. This is the bearing mount on the front here, and on the back I've got the motor mounts. I've already got the Acme lead nuts that we talked about the other day. I've got those all installed on the little holders here. I did have to cut another one here, because I found out that I was about 95 thousandths too short and it wasn't lining up good, and it's because I put a couple extra washers in here to space this out. So I went ahead and recut another one of those, and now when I eyeball it, I can tell it's perfectly concentric looking across through there. So got to get the lead screws cut. I'm going to take some measurements. I'm going to go cut those, and then I'll come back and we'll start going through mounting the motors and the lead screws and the couplings and all that on here, and get ready to fire this thing up. But I thought I would show you here. I've got my let me get something to open that with. Picked up this kit today. It came. They tried to deliver it yesterday, and I had to go to the post office this morning and get it. Haven't even opened it yet, but this is the stepper motor, controller. There's a parallel cable, power cord. This is I don't know if I mentioned this company's name. This is from Xylotex, and I would highly recommend, if you're building your own, to buy from Jeff at Xylotex, because this thing is the bomb. I mean, it's totally turnkey. You get it opened up and you just plug everything up, turn it on, and pretty much go, other than set your settings in Mach 3 or whatever controller software you're going. But here's the controller. It's already pre-wired, ready to go. Here's the stepper motors. Let me just see if I can get one of these out here so I can show you. I was showing you the other day that spare one I've got, but see, they come with these connectors. I mean, you can't get it any easier than this, guys. It's all plug and play. I bought, probably 100 of these from Jeff over the years, and I've never had a single one not work as soon as I pull it out of the box. So think about that when you try to do this. You might find them cheaper somewhere, but I guarantee you it'll be more of a headache, because you'll have some soldering to do or something to do. This is all ready to go, and just really super easy. So, and that's the kind of kit I wanted to go with since I'm showing people how to build your own, because I know a lot of people, because I'm that way too. I don't know electronics. If I have a thing that says put the blue wire to here and the red wire to here, I can do that fine. But it's a whole lot easier if everything is all automatically just done for you. It's color coded, so you can't put the wrong one on the wrong axis. Very simple, which you'll see in a little bit. So right now I'm going to go take these lead screws around to my garage, use my angle grinder to cut them to length, and then when I get back, we'll get this thing fired up. Okay guys, I got the lead screws all cut. Got the stepper motors all installed, got everything connected. I went in the house and drug out an old PC. This is a old compact Pentium 3, which is plenty of horsepower. You just don't need a lot of computer horsepower to run one of these things. It's running Mach 3 controller software, which is what I always use. It's already got the settings in it for the pitch and the lead screw, which we'll go into once we get a little farther along into this. But at any rate, I'm ready to hit the switch, and we'll see what happens. Hopefully this thing will take off and run. So let's flip the switch and see what happens. Alright, maybe you can hear the controller powering up there. Now let's just try to jog this a little bit and see what we get. Okay, looks like that one's moving well. Looks like that one's moving okay. And we've got some movement there. Try just running a little test program here. Now maybe you can tell in this shot, I don't know, I haven't fastened these bearing mounts and the motor mounts. I've just kind of got them clamped on there right now. I wanted to run this a little bit and make sure that everything is running smooth, because you do need to have all this in a line so there's no binding, to make sure it runs smooth. Notice, as I mentioned before, we're using dual lead screws on the long axis here. You can call that the x-axis, or you can call it the y-axis, depending on how you program. Some people like to stand on the side over there and call it the X. Other people would stand in front here and call it the Y. Pretty much the same thing, it just depends on how you set up your thing. Looks like everything's running pretty good. I'm real pleased with how this little machine turned out. And I want to go over a couple of questions. Let me turn this off, maybe it'd be easier to hear me. I'll stop it there. I want to answer a few questions because I know I've had some people already asking some questions. One of the questions that I got the other day was somebody wanted to know, I mentioned I'm using 3/4 birch plywood. I just bought it at Lowe's. That's what I'm using for the construction. Pretty much every wooden part is 3/4 inch birch plywood. And somebody says, well, how many sheets do you need? Well, for this size machine, you've got a 4-foot table it's about 26 inches wide. It's going to give you a cutting area of, I don't know, about 35, 36 inches this way by 24 inches this way. And all these parts were cut out of a single sheet of plywood. And really it doesn't even use near a sheet of plywood, because it took me a little more, because I cut these parts using my CNC. So when you're cutting blanks to fit on my machine, sometimes you can't get them nested properly, and you have so you have more material waste that way. But if you're just laying these out and cutting these out, rough cutting them with the bandsaw, and then maybe fine tuning them with a scroll saw or whatever, you should easily get all of the parts for this little table or this whole machine out of one sheet of plywood. I used two 8-foot 2x4s to make the frame, the table frame. You saw that in one of the previous videos, nothing fancy. Another question I had is, somebody was looking at, I guess the last video, and they said, it looks like after a period of time, this would get all screwed up from cutting, and you would need to replace it. No, you don't want to replace this, but you don't want to cut on it either. When you've got your router on here, you want to, anytime you're cutting all the way through, if you're just putting something on here and engraving it, and you're not going all the way through it, that would be fine. You can fasten it down directly to this. If you're cutting something where you're parting it out, cutting all the way through it, for example, like when I cut 3/4 inch plywood, I program it to cut to a depth of 0.78. So figuring that the plywood might be right around 3/4 or 750, 780s about 30 thousandths below, so you want to go just past. But what I do is I put some people call it spoiler board, I just call it a sacrificial piece of material, whether it be MDF. I like to use HDPE because I've got a lot of scrap skeletons from things I've cut, and I'll put one of those on here, then put my workpiece, clamp it down, so I never hit my table. So unless you screw up when you make this, you know, if you always use a spoiler board or a sacrificial piece of material, you should never have to replace this. I'm not saying you won't screw up, because you probably will at least once, but not so, you know, hopefully you'll catch it and it'll just leave a mark and you won't have to replace it. But so that answers that question. Another question is, somebody's asked me, okay, how much, you know, I'm calling this how to build a CNC on a shoestring budget. So I said, well, how big a shoestring have you got? You know, well, I'm going to grab the receipts here in just a little bit, and we're going to go through and add this up and see. But I think it turned out pretty good. I'm probably not going to do a whole lot much more on this video. It looks like it's moving pretty good. I found some leg levelers that I had for another project. So what I did earlier today is I took just a little block and I cut 4 of them where they're exactly the same height, and then I put a T-nut in there so that I can, you know, when I set this down on a table or something, I can level it up, and it will stick up enough to where these sides of the gantry will excuse me, will clear. You'll have to excuse me, I've had a bad cold all week, been fighting it. So anyway, let me grab the receipts and I'll turn the camera back on, and we'll go through and add some of this stuff up and see about where we're at. Okay, I'm going to try this again. As I mentioned a while ago, I've had a bad cold all week, and every time I get ready to shoot this part, I get into a coughing fit. So I had to run in the house and get me a cough drop. So maybe I can make it through this time. Anyway, I've been sitting here tallying up the receipts. Saved the receipts. I've been just throwing them in a box over there. But now that the build is pretty much complete, let me go through and we'll tally this up. First thing I bought was one sheet of 3/4 birch plywood. Got that at Lowe's. That was $50.97. I bought 2 2x4s. You know, if you watched the other video earlier, you saw me build the ladder frame for the table that's underneath this piece of plywood. Both 2x4s, the total was like $6.78. They were like $3 and something a piece, I think. No big deal there. Okay, another thing, one of the first things I bought was these V-groove bearings. I researched those, found them online. They were as much as like $12 a piece, and you got to buy like 16 of them. But I did find an eBay store that I'll have a link to when I put all the details about this up on my website. I found an eBay store where I bought a pack of 16 for $85.60, which, if you do the math, that's like $5.35 a piece. So really good deal on those V-groove bearings, and it's something I think, you know, it's an eBay store, so it looks like that's kind of a regular price. It's not like they were on sale or anything, so you can pretty much go in there anytime and get them for that, looks like. The aluminum angle here on the Y-axis or Y-axis or the X-axis, whichever you want to call this, and the Z-axis is all 3/4 by 3/4 by 1/8 aluminum angle. I got that from Master Car. The length was, I think I bought an 8-foot length, and it was like $14.29, and I bought 2 of them, so I've got about $28.58 in aluminum angle here. The table, again, I bought this from Master. I bought 2 8-foot lengths of 1 by 1 by 1/8 angle, and they were a little more. They were like $18.97 a piece, for a total of $37.94 for the angle for the table. Okay, now we're starting to get into the more expensive stuff. The couplings, which are all the couplings on these motors, and I talked about how great those things are, because They save you so much time. You don't have to put your lead screw in the lathe and turn it down. They're whatever you order, whatever coupling for whatever type of lead screw you're using. These are 1/2 x 10 5 start. The guy taps these couplings on one end, 1/2 x 10 with 5 start, so they just screw right on. You fasten them on. Saves you a ton of time. A little more expensive than some other couplings probably, but well worth the money. I wouldn't do it any other way because it just saves you a lot of time. You don't have to put them up on the lathe. And the Acme nuts, which would be right here, here. You know, I've got 4 of those. So I got 4 couplings, 4 Acme nuts, and they were where are they here? $174 for those 8 items. Like I said, may sound a little high, but the way they are, there's makes the job putting this thing together so easy. I wouldn't go any other way. I really like not having to, because all you have to do with your lead screws is measure to get the length right, cut them off with an angle grinder or, you know, whatever, hacksaw, file the burrs off, and then screw that on, fasten it down, you're done. No lathe work or anything. So $174 for those 8 items. Another thing that's a little pricey are these Acme lead screws. I got these from McMaster. I've been buying these from McMaster for years. They're 1/2 x 10 5 start, which means that with the 5 start, it means it takes 2 revolutions to move an inch, as opposed to a single start where you'd have to turn 10 revolutions to move an inch. So you get a little bit faster rapid speeds and things like that with these. Really suited for a small CNC like this. Those are a lead screw. They come in like 6-foot lengths, and the bad thing is they come in kind of I think you can get them in like 1 foot, 3 foot, and 6-foot lengths. Well, the bad thing is these 2 pieces here on this long axis are 48.5 inches. So you know, you cutting off some drop there. You can use 1 piece of the drop for this Z. So you can buy 2 6-footers, and with the cutoff of one of them, you can make your Z axis. But then you got to have another one, or you could buy a 3-footer, I guess, to do this this axis here, because this one's about, I don't know, 31 inches or so, something like that. I'll have to go back and measure all this stuff. But those things are, for a 6-foot, they're like $66.50, and I bought 3 of them, so that's $199.50. Sure, I didn't use them all. I've got some for another one, but you know, they're a little pricey too. But again, I think they're a good choice for this size CNC. Let's see what else we've got. The bearings, which are, I don't know if you can even see them because they're turned around where you can't really see them, but I've got them inset in here where they're on this side, but it's where it helps support this end of the lead screw. You can see one right there. There's also one right here. So I bought 4 bearings. They're just 1/2 inch, and they're about an inch and an 1/8 OD. So you know, if you're making these by hand, you'd use like a Forstner bit or something to make a pocket. They are $9.86. You might be able to find those cheaper somewhere else. I just ordered them from McMaster because I know they've got them. Let's see, what else? Okay, the really big ticket item, it looks like I've talked about everything else here. The really big ticket item is the controller and the stepper motors. And again, you know, I know I've been bragging on Xylotex, but I've bought probably, I don't know, Jeff could probably tell you, but I've probably bought close to 100, you know, 3 and 4 axis kits from him over the years, and they just always work. You know, you pull them out of the box, they're all plug and play. They just work, and you know, you just plug them in and it goes, so you don't have to worry about anything. You know, it's all the wiring's done. Everything is color coded. You know, they have a Molex connector right here. The way it's designed, it's impossible to plug it in the wrong way, which would really make for a bad day. But it'll only go together one way so that the wires line up. All the motors are the same. They're not color coded, but you notice this wire is red. This one up here, I don't know if you can see that, it's green. The two in the back are yellow and blue. So all of them are color coded. You can figure out which one you want to use for which, and set up your controller with the proper setting. Really easy to do. And if you've got, like me, where you've used that computer before and your settings are already in the computer, it's real easy. You say, okay, this is green, it goes here. This is red, it goes here. Really, pretty much makes it idiot proof to do it. Another thing I might mention, I've got a lot of hardware here, these dowel nuts, a lot of screws, big bolts here. I just kind of tallied them up. Some of them I bought from Ace Hardware, some of them I bought from McMaster. I've got a little less than $100 worth of miscellaneous hardware, I guess. It does kind of add up though, because there is a lot of bolts and screws and nuts and what have you. But anyway, when I totaled that all up, it came up to $1,107.81. So just a little bit over $1,100. I don't know really where you could go and get you a CNC like this one for or any kind of CNC really for $1,100. You might be able to get one of those Chinese things or something, but I don't know. I think this is I wanted to try to build this one as inexpensive as possible, but I also wanted to build something that's worth having. And trust me, I know that if you've got a CNC and it's got a lot of slop, you really don't have anything. I talked about how expensive these lead screws are. Yeah, you could probably just go to your local hardware store and buy some half 13 threaded rod and use a big old nut and stuff like that. But there's too much slop. There's just way too much slop. You wouldn't be happy. It wouldn't cut worth a flip. So, you got to spend the money on the right thing. So, anyway, maybe this video will probably get you guys going as far as thinking of some more questions. So, put your questions down in a comment or email them to me or whatever. And on the next video that I do, we'll answer some more questions. I'll show some things for all the newbies, how to zero the machine, how to set up the controller software, which is important. I didn't really have to do it because I already had that on that computer, because that's one I'd used before. And it's basically what pitch lead screws you use. If you know the steps per inch and all that, and I'll show you how to figure that. It's real easy to set one of these up, because when you program it and you tell it to move 4 inches, you want it to move 4 inches, not 2 or 4 or 8 or whatever. So anyway, so that's going to wrap it up for this video, I think. Like I said, if you got any questions or comments or anything about this build, feel free to leave them below. I appreciate all of my new subscribers. Man, I've just been getting, I don't even know how many subscribers now. I'm up over 4,100 or something like that. I don't know. Just real happy about that. Thank you all for subscribing. Thank you all for all the kind words you said. I've had a lot of good comments about this build. Hopefully this will inspire some people to try to build this. And like I said, we're talking about this one totaled up to about $1,100, but you don't have to do that. You don't have to go out and buy all this stuff at once. If you just buy a little at a time, I mean, it wouldn't really do you any good to buy all this stuff, and because it's going to take you a while to get the machine parts built and get them put together and all that. You just buy it as you go, and it wouldn't really be that bad. So anyway, that's going to do it for this video. Thanks for watching. If you are not a subscriber to this YouTube channel and you like what you see, please hit the subscribe button. Hit a thumbs up too if you like what you see. And we'll talk to you next time. Thank you.